a review of algebra sheet that I'm moving to my grade 9s this term. So term 4 we are focusing on algebra and quadratics. So in particular expanding and factorising quadratic equations and expressions. So having a look at the first one, we're looking at expanding two sets of brackets. Now I like to use what we call the smiley face method. So I draw in the lines there. I'm going to color code these so that you can see which part I'm doing each time. So I call those top ones the eyebrows, and then I've got the mouth, and then I have the nose there. I'm just going to grab another pink highlighter because that one just broke. So the first one I do is the orange line, so the x times the 2x. That's this part here. Then I'm doing that yellow line, the 3 times the -5. So there's that yellow there. Then I'm doing my big smile. So I've got the x times the -5 there. And then I've got the nose, which is that green line there, the 3 times the 2x. Then I'm going to go through and simplify those. So x times 2x gives me the 2x squared. The 3 times -5 gives me -15. The x times -5 gives me -5x. And the 3 times 2x gives me 6x. Then I will go and collect like terms. So the 2x squared, I don't have any other x squareds, so I just write 2x squared. My -15, I don't have any other constants, so that's there on the end. -5x plus 6x gives me the plus x. I've then got 2 there for you to have a go at. So you might want to pause this video, have a go at those questions yourself, and then play it back to see if you got the answers correct. I'm going to go and do these questions now. If you want to pause, have a go yourself, and then turn it back on when you're ready to check your answers. Have a go at that. So I'm going to use the same colours again as I did in the one above. So I'm going to do my m times m, and then I've got 3 times -2. Then I have the m times -2 and the 3 times m. So I get m squared, take 6, plus -2m plus 3m. So that means I'm going to have m squared, I'm going to have plus m there, and take 6 on the end. Then this one over here, I'm going to have a times 2a plus 4 times 3 plus a times 3 plus 4 times 2a. So that's going to give me 2a squared plus 12 plus 3a plus 8a. So I get 2a squared plus 11a plus 12. The next type that we have looked at is when we have special patterns. So one of those special patterns is our difference of two squares, where we have a plus b, a minus b. So we've got two sets of brackets, opposite signs, but the same things in the brackets. And when we have that, we end up with a squared minus b squared. Now we could do it the method that we used up here and get to our answer, but having the pattern makes it a lot quicker. So we've got 3 here that I'm going to show you. If you want to pause the video, have a go at them, and then check your answers, that's a good option. Here we've got x plus 3, x minus 3. So that's going to give me x squared minus 3 squared, which I can then write as x squared minus 9. Here I've got x plus 5, x minus 5. So I'm going to have x squared minus 5 squared, which will be x squared minus 25. This last one I've switched it round, but we can still do it the same way. So we've got 4 squared minus x squared, which will be 16, take x squared as our answer. Then we have our perfect square pattern. So that's where if we have one bracket that's squared, we're going to have whatever that first term was squared at the start, whatever the second term was squared at the end, and in the middle, 2 lots of whatever's inside the bracket. Because if we went back to that original method, that would be what we are doing in that process, and we would have 2 lots of that nose and mouth. They would be the same, so it'd be 2 lots of that answer. So here we've got x plus 3 squared. So I'm going to have an x squared on the end, at the front, a 9 on the end, because that's x squared, 3 squared, and in the middle I'm going to have 2 lots of x times 3. So that will give me x squared plus 6x plus 9. In the next one I've got x plus 4 squared, so that means I'm going to have x squared at the front. On the end I'm going to have 16, and the middle I'm going to have a 2 times x times 4, so that will give me x squared plus 8x plus 16. Then the last one here we have is x plus 5 all squared, so we're going to get x squared plus 2 times 5 times x plus 5 squared, and we get x squared plus 10x plus 25. Now here I've got a little working backwards question that I'm just showing the process for. We're going to do a little bit of the factorising on the back of this sheet. So we've got x squared minus 9. We can write that as x squared minus 3 squared, and then we can write x plus 3, x minus 3, just to link it to that expanding version, and then they're going backwards. And the same way here, if we've got x squared plus 6x plus 9, we can write that as x squared plus 2 times 3 times x plus 3 squared, and we can see we've got that 3 there, the 3 there, the x, so we're able to write that as x plus 3 all squared. Going on to the second side of the sheet, we're doing some factorising. So starting just with common factor. So we've got 5x minus 10. I've broken that down to 5 times x. Take 5 times 2. I've circled the 5. That's gone out the front. And inside the bracket goes the x take away 2. So I've got 2 over here for you to have a go at. You might want to pause this video, have a go at the questions, and then play it to watch the answers. So for the first one we have is 4x minus 8. I'm going to break that down to 4 times x minus 4 times 2. I'm going to circle that 4, and I have 4 outside of x take away 2 as my answer. With the second one, we've got 6 and 9, so we can write that as 3 times 2 and 3 times 3. And then we've got times x times y there, and times x times y times y. So I'm able to circle the 3 in both terms, then the x and a y. So that means I can put 3xy out the front, and in the bracket I'm left with 2 plus 3y. Then we get into factorising by grouping. So this is starting into our factorising quadratics methods, and this is part of that process. So breaking it down a little bit before you get into the full method, where we've got the grouping. So we look at we've got 4 terms here, x squared minus 5x plus 2x minus 10. So I'm just looking at the first 2 terms, x squared minus 5, and factorising that. And I can take an x out the front, and then I have x minus 5 in that bracket. Then I look at the second set of 2 terms, so the third and fourth. They have a common factor of 2, and then in the bracket would be x minus 5. I can then see that I have that common bracket of x minus 5, so I can separate that out. I might have written it first, usually, and then the leftover goes in the other bracket. So I've got my x plus 2, and that's how I end up with my 2 sets of brackets. Having a look at the next 2, you might want to pause it, have a go, and then watch the video. So we've got this one here, we've got x squared plus 4x plus 3x plus 12. Looking at those first 2 terms, they have a common factor of x. So I'm going to write x outside of x plus 4. The second 2, or the third and fourth term, have a common factor of 3. So then in my bracket would be x plus 4. I can now see I have that common bracket of x plus 4. So I can bring that out the front. There's my x plus 4. And I'm left with x plus 3. So that's what's going to go in my other bracket. Now you don't have to be color coding yours. I just do that so you can see what I'm doing when I do the process. For part B, I've got x squared plus 2x plus 5x plus 10. So looking at the first 2 terms, I have a common factor of x and x plus 2 in the bracket. Second 2, I have a common factor of 5, x plus 2 in the bracket. So my common bracket is x plus 2. That can come out the front. And then in the second bracket is going to go my x plus 5. Okay, in the last question on this worksheet, it's using our special patterns, the difference of two squares and perfect squares, to factorise this set of expressions. So the first one I've got is x squared minus 25. So I can see that's going to be a difference of two squares. So my first step will be to write that as x squared minus 5 squared. And then once I've got it in that format, I'm able to write x plus 5, x minus 5. So we want to be able to write them both as something squared, and then we know that's the bits that are going to go into that bracket. Here we've got 36 minus a squared, so we can write that as 6 squared minus a squared. So in my bracket is going to go 6 plus a and 6, b there, 6 minus a. Now my last one is a perfect square one. So I'm looking at that going, I know 25 is the same as 5 squared. I've got my x squared there, and I just want to check that this middle one is going to be 2 times x times 5. And 2 times 5 is 10x, so I know that's correct, which means I can now write x plus 5 all squared as my answer.